This video will help you to figure out how many protons, neutrons, and electrons in a particular atom. What you see here is a particular way of symbolizing fluorine. Fluorine is abbreviated with the capital letter F. Fluorine has an atomic number of 9. If you look it up on the periodic table, it's going to have this number 9 with it. That's going to tell you specifically the number of protons that fluorine has. So if the question is how many protons does this fluorine atom have, the answer would be 9. Next, we're going to look at neutrons. To do that, we have to look at this quantity called mass number. Since protons and neutrons have a mass of 1 AMU, and the protons and neutrons are the only substances that we consider mass-bearing within the atom, we would add the number of protons and neutrons together to get what's called the mass number, or the mass of the atom. Since in this case, there are 9 protons already, and the mass number in total is 19, this becomes a subtraction. In other words, 19 minus 9, which means that this particular atom of fluorine has 10 neutrons. Lastly, we need to look at electrons. In this particular situation, there's no indication that this fluorine atom has a charge. Therefore, the number of protons and the number of electrons must be equivalent. In order for there to be no charge, the positive character and the negative character must cancel out. So in this particular situation, since we have already established that there are 9 protons, we will also have 9 electrons. This particular atom could also be referred to as fluorine 19. This is because it has the mass number of 19, and the number of protons can be assumed from the periodic table to be 9. So sometimes you'll see the nomenclature that looks like this, where you have the atomic symbol with the mass number up and to the left, and the atomic number down and to the left. And sometimes you'll see this sort of writing, where you'll have the name, sometimes the symbol, followed strictly by the mass number. Here's another example. Calcium. This particular calcium atom has an atomic number of 20 and a mass number of 40. Remember from the last slide, that means that if the atomic number is 20, it must have 20 protons. Since it has a mass number of 40, and we know 20 of those are protons, that leaves us with 20 neutrons. Remember, mass number equals protons plus neutrons. Lastly, we have our electrons, and since this here is not charged, there's no indication of charge here, our assumption is that the electrons have to be the same number as the protons. So here, we'll have 20 electrons to 20 protons. That'll mean that the charges cancel out, and the overall charge on the atom would be 0. This atom could also be referred to as calcium 40, for its mass number of 40. So to recap, atomic number is equal to the number of protons. Mass number is equivalent to the number of protons plus the number of neutrons. We can rework this equation to solve for the number of neutrons. In that case, you'd have the mass number minus the number of protons, giving you the desired quantity, the number of neutrons. So that mass number equation can be used in a couple different ways. Lastly, for electrons, we know that when charge is 0, the number of protons is equivalent to the number of electrons. So there it is. You can figure out protons by looking at atomic number. You can figure out neutrons by looking at mass number and number of protons. And lastly, you can figure out number of electrons by noticing when you have a charge of 0, electrons and protons are equivalent. Thanks for watching, and that's that.